Welcome to question 4 of the 2011 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 4 we have if the function f has a rule f of x equals the square root of x squared subtract 9 and the function g has a rule g of x equals x plus 5. For part A, we're asked to find integers c and d such that f of g of x is equal to the square root of the factorised form x plus c times x plus d. So to attempt this question, we're going to start by looking at the composite function, which is f of g of x, and that is going to equal, and f, the outer function, is the square root of x squared minus 9, which I'm doing in blue, so we have the square root of, but instead of x, we're going to have g of x squared minus 9 under the square root sign. So the composite function f of g of x looks like this now. And our job now is to simply change this into the form that was requested of us. So we have f of g of x is going to equal the square root of, and now we're going to expand out x plus 5 all squared, and this one you just need to be a little bit careful of. This is where a lot of students would make a mistake. So we'd have x squared plus 10x plus 25, and then we still have minus 9. So therefore f of g of x is going to equal the square root of, and we can simplify x squared plus 10x plus 25 minus 9 by collecting like terms. So we're going to have x squared plus 10x plus 16, and now we have an expanded quadratic that we need to factorise. So to do that, we're going to look for the factors of positive 16 that add up to positive 10. So the factors of positive 16 are 1 and 16, 2 and 8, 3 doesn't work, but we get 4 and 4 does work. So we find that 2 plus 8 does in fact equal 10. So this is the information we're going to use to help factorise this. So therefore, f of g of x, which is what we were dealing with the whole way through, is going to equal the square root of, and now in factorised form it's going to be x plus 2 times x plus 8. However, we're not quite done yet. We still need to find the integers c and d, so we're going to state what they are. So as it's written at the moment, you might say that c is equal to 2 and d is equal to 8. So that is the answer to part A of this question. However, equivalently, we could also have written c is equal to 8 and d is equal to 2. So either of those answers would have been permitted for this question. So from the examiner's report you can see that 75% of students got full marks for this question, and the examiner goes on to say that the majority of students gained full marks for this question. However, many did not state the values of c and d, and others factorised incorrectly or did not expand x plus 5 squared correctly, which is something that we pointed out on the previous slide. For part B of this question, it asks us to state the maximal domain for which f of g of x is defined. So firstly, I'm just going to write down the rule that we found before, that f of g of x was equal to the square root of, and in factorised form it was x plus 2 times x plus 8. And now when we're considering the domain of a composite function, usually we'd look for the range of the inner to be a subset or equal to the domain of the outer function. However, as it's written with f and g, this is a lot more complex than it needs to be. What we essentially need to think about is what is the outer function. If we do our own composite function, we could treat the outer function just to be the square root of x. So this is just y equals the square root of x, and it has an endpoint of 0, 0. So we can see the domain of that is all positive numbers and 0. And then our inner function, so to speak, could be this quadratic. And if we were to sketch that, we would have a quadratic with x-intercepts at -8 and -2 using the null factor law, so it would look something like this. And that there would be -8, 0, and this would be -2, 0. And now we can simplify down what this question's really asking for. So for f of g of x to exist, we need x plus 2 times x plus 8, so what we're treating now as our inner, to be greater than or equal to 0. So that means that the y values coming out of that quadratic fit inside the domain, which I'm just doing over here in yellow, of the y equals the square root of x function. So from our second graph, we can see that y values greater than 0 occur here, which is x is negative infinity to negative 8, and also from negative 2 to positive infinity over the other side of the graph here. So therefore, the maximal domain is going to be x is an element of, and what we just discussed before is if we put negative infinity until negative 8, and we can include that because 0 is allowed under a square root sign, and we union that with negative 2, included to infinity, not included, that is the domain of the composite function f of g of x. So that is the answer to part B of this question. So the examiner's report says that this question was done very poorly. So only 10% of students got full marks, and only 6% of students got 1 mark, with 84% receiving no marks for this question. The biggest thing we can take away from this examiner's report is that students just needed to look for the domain that would make the square root function work. And we discussed before that that was just having positive numbers or 0 under the square root sign.